So let's talk about acceleration. When I think of acceleration, I think of speeding up. But all of you guys have heard of deceleration. And deceleration is the opposite of speeding up. It's actually slowing down. What you guys need to know is that acceleration is actually the rate at which the velocity of an object is changing. Notice how I didn't say speeding up or slowing down. I just said the rate at which the velocity is changing. So, velocity we know is displacement over time, or the direction of the speed changing. Okay? So, positive acceleration is when the velocity is increasing. Negative acceleration is when the velocity is decreasing. And let's talk about the equation for acceleration. Okay? All acceleration is A is equal to delta, which delta just means change in velocity over the change in time. Or the way I personally like to write it is the final velocity minus the initial velocity over the final time minus the initial time. This is important. I want to remind you guys that you guys will be given the basic equations for your guys' semester exam and your final exam, and also your unit tests. However, you will be responsible for having to rearrange them. You will not have to rearrange this. You should be able to plug and chug. However, any of those equations where you have three variables, you are going to have to be able to rearrange those equations accordingly. Okay, so we're going to start with Raj. Raj drives monster trucks on the weekends. His truck decelerates. Remember what decelerate means. It's the velocity is decreasing, okay? So the velocity is going down, we know that, from 72 meters per second to 0 meters per second. So this first one, since it's saying from, is saying the initial, okay? So the initial velocity is 72, that's V1, okay? The final velocity, or V2, is 0 meters per second. So it stops in 6 seconds. That's our time. What is the rate of the deceleration? So if we're decelerating, do you think this is going to be positive or negative? It's going to be negative because we're going slower over time. So don't get thrown off if you get a negative. What that tells you is that you are decelerating or you are losing velocity. So we know that acceleration is equal to velocity 2 minus velocity 1 all over t2 minus t1. Now, rule of thumb, because we were just given one time, this can just be time, okay? So what we do is we take velocity 2, which is 0 meters per second. We subtract 72 meters per second. And we put that over 6 seconds, because that's its total time. That's the change in time. Well, 0 minus 72 gives us negative 72 meters per second, and we've still got that 6 seconds. So we take negative 72 divided by 6, and we get negative 12. This is something that is going to be confusing for you guys at first in terms of units. Notice how seconds is on bottom here, but it's also down here. We can't cancel those out, okay? And we also can't leave the meters. So velocity is really interesting. Acceleration is really interesting, rather. 12 meters per second squared. So anytime you're solving for acceleration, it's going to be whatever the measurement is, okay, or the distance over whatever that time is squared. Okay, that's what your units are going to be in. Okay, and that'll take some practice. Okay, if it was meters per second, it'd be speed. If it was meters per second north, it would be velocity. But the way we can identify that this is acceleration is because it's meters per second squared. All right. Oh, we got Jackson. Jackson Hoovler loves to sled down hills in the wintertime. If he hits a speed of 50 meters per second after 5 seconds, what is his rate of acceleration if he starts at 0 meters per second at the top? So, what would this be? That would be velocity 1, because that's his starting velocity. This is his final velocity, and this is his time. So again, acceleration is equal to v2 minus v1 all over the change in time, or the time, okay? And because the change in time is usually the initial t1 is going to be 0, because you start at 0 seconds, and t2 is your final, that's why typically it's just over t, okay? So what you do is you plug in 50 meters per second minus 0 meters per second all over 5 seconds. Well, this gives us 50 meters per second over 5 seconds. You guys should be able to solve this in your head, but 50 divided by 5 gives us 10. So that gives us 10, and how do we do these units? We've still got meters, but now we've got 2 seconds. So seconds times seconds is seconds squared, okay? And that's a positive, and that's why we know it's accelerating. It's a positive acceleration. Alrighty, number 3. Damien just got his driver's license. Congratulations, Damien. And he speeds up from rest, and rest is 0, to 0.007 kilometers per second in the span of 3 seconds. What is his rate of acceleration? Okay, so if it's hard for you guys to identify the variables writing it out like this, let's write it out this way, okay? What is V2? What is V1? What is the final time? And what is the initial time? Okay, so he just got his driver's license and he speeds up from rest. If you're resting, you're staying still. So your initial velocity, because you're speeding up, is 0, okay? So you can just write 0 there. Velocity 2, or the final velocity, he speeds up from rest to 0.007 kilometers per second. All right? He does this in the span of 3 seconds. So he started from 0 seconds. Okay, that's why we just usually put it just over t. The final time, though, is 3 seconds. So we know acceleration is equal to v2 over v1 divided by t. So v2 equals 0.007 kilometers per second minus 0 over 3 seconds, and you could put minus 0. What you're going to get is 0.007 kilometers per second over 3 seconds. You're going to type this in, 0.007 divided by 3, and you get 0.0023 repeating. Okay? And what are those units going to be? We've got kilometers, and we've got 2 seconds that are going to multiply by each other. So it's kilometers per second squared. Do you see how, again, the distance is going to stay consistent, okay? So if that's in centimeters, if it's in kilometers, if it's in meters, if it's in feet, if it's in yards, that's going to be the same. But the time, so if it's in days, if it's in seconds, minutes, hours, years, that's going to be squared. And if you need to talk that through, I'm happy to talk that through with you. Alrighty. Number 4, we got Phoebe. Phoebe takes a train to visit the love of her life. How romantic. She might not have her driver's license. Her train travels at a speed of 10 meters per second at the top of the hill. So let's do this again. We have velocity final, we have velocity initial, we've got time final, and we've got time initial. And the way we know these variables is we know that acceleration is equal to the final velocity minus the initial velocity over time. Okay? So her train travels at a speed of 10 meters per second at the top of the hill. So the starting point. So 10 meters per second. 5 seconds later, it reaches the bottom of the hill and is moving at 30 meters per second. So that's her final velocity, 30 meters per second. What is the rate of her acceleration? It says 5 seconds later. Because it says that, we know that that's the amount of time. And it starts at 0 seconds. Do you see why we usually just don't take into account that number? All right, so plug these in. Velocity final is 30 meters per second. Subtract that from the initial velocity, 10 meters per second, and divide that by 5 seconds. All right, 30 minus 10 equals 20, so 20 meters per second over 5 seconds. Let's enter this in. 20 divided by 5. If I could type that in, that'd be great. 20 divided by 5 is 4. So that gives us 4 meters per second squared. All righty. Go ahead and flip over your sheet. Number 5. Kaya starts her aunt's car from rest. Uh-oh. All right. And after 5 seconds, she is traveling at 35 meters per second. What is the rate of acceleration? Well, she starts it from rest. So that's velocity 1. 5 seconds, that's going to be our time. And she's traveling then at 35 meters per second. That's the last one they give us. So that's velocity 2. What is the rate of acceleration of the car? We know that acceleration equals V2 minus V1 over time. So V2 equals 35 meters per second. V1 equals 0 meters per second, because that's rest, divided by 5 seconds. So all this is saying is 35 meters per second divided by 5 seconds. You guys should know how to solve this, but I'll do it on the calculator anyways. 35 divided by 5 equals 7. So that gives us 7. Meters isn't going to change, but we're multiplying second by second, so it's second squared. All right, number 6, McKenna. McKenna throws a shoe at her brother. I don't know which one. Starting at a speed of 50 meters per second. So that's velocity 1. Remember, speed and velocity are the same thing. Velocity just has a direction. She's throwing it at her brother, so the direction is towards her brother. And accelerates to a speed of 150 meters per second. So that's velocity 2. In 5 seconds. So that's the time. What is the rate of acceleration? We know that acceleration is equal to velocity final minus velocity initial over time. So what we're going to do is take 150 meters per second minus 50 meters per second all over 5 seconds. All right, so let's simplify this. 150 minus 50, 100. Units are going to stay the same. Divided by 5 seconds. Okay, guys, I'm not using the calculator. 100 divided by 5 is 20. And because we are doing acceleration, it's going to be meters per second squared. All right. Last but not least, guys, I really want you guys to get in the hang of being able to read these problems. And yeah, I'm going to ask you what I'm looking for, but I need you guys to help find the variables that are included. So here, I went ahead and wrote out the equation. These equations are going to be given, okay? So you know that since I'm solving for acceleration, I need the final velocity, then the initial velocity, and the time, and you should be able to pick that out here. That's how on this side, I was able to just write out V2, V1, T2, T1, okay? So let's go through some of these together. Based on the units, you should be able to tell, okay? And we have D for distance, T for time, V for velocity, and A for acceleration. So, 14 kilometers. Distance. All right? 30 meters per second south. So if it was just this, 30 meters per second was your speed. But because we added the direction on it, it's velocity. All right? 34 minutes. Time. 6 hours. Time. 12 centimeters per second squared. Look familiar? All right, acceleration. 150 miles per hour northwest. If it was just this, it would be speed. Because it has the direction, it is velocity. All right, 14 miles. Distance. 32 seconds. Time. 25 feet. Distance. All right, make sure you come to me if you have any questions. I encourage you to do those extra activity worksheets to prepare. And there are also some attached flashcards for vocab terms if you need any extra help. Thanks, guys.